Welcome to True Projects. In this video, we are going to explain about the project that is this code the best or can it be further improved? Developer stats to the rescue. Before getting into the execution, first let us understand what is the project about. In the fields like high performance computing and scientific computing, that is HPC and scientific computing, where every millisecond counts, the quality of the code is not just about getting the job done. It is about getting it done as efficiently as possible. When a project manager looks at the code that team develops, they often have to make an important decision that does this code meet the highest standards or could it be optimized further by an expert? Unfortunately, there isn't a clear way to answer that question yet. Right now, there are no standard methods or tools that can tell you if a piece of code is the best. It can be further there it could be further still room for the improvement. Even though we have metrics like experience, rank, or the position in coding context, they don't really help in answering these specific questions. They can't pinpoint if a developer's code could be made more efficient or how much better it could be with expert level insights. This gap This gap in evaluations is especially problematic in high stake environments like HPC when performance is everything. It's like without a reliable way to measure and predict potential improvements, it becomes difficult for managers to assess whether the team's code is already as its best or if it could reach even greater efficiency with the help of an expert developer. This problem highlights the need for a method or tool that can objectively evaluate and quantify the improvement in potential in code. One of the major challenge, One of the biggest challenge in software development is determining whether the code written by a team is of the biggest quality or if it can be improved. Currently, there are no standardized ways to measure the quality of the code on developers' ability. While platforms like Codeforces they provide data on developer performance, this data isn't effectively used to assess code quality on expertise. In the fields like HPC, where performance is critical, this issue becomes even more pressing. Without reliable method to evaluate code quality and developers' expertise, optimizing the coding process and final product becomes difficult. So there is a clear way for a systematic approach to quantify developers' ability and assess the code quality, which can help managers make better decisions and improve the software quality. This project is designed to figure out how good a developer's code really is, and it does this by using unique metric called quality index, which basically scores how well a developer writes quality code. And the system pulls data from. So in this project, we have used the data from coding competitions on platform like that is Code Forces to understand how developers have performed in the past. By looking at their contest results, the system can assess key things like whether the code is correct, complete, and efficient. And now developers don't always perform at the same level, right? Some might have great contests, but other times not so much. So the system filters out any inconsistencies by focusing on only on the top performance. It uses a method where it looks at the best developers and calculates the quality index. It calculates the quality index and then the top performers are filtered out. The quality index is normalized. So if the score is closer to 1, that means that code quality is really high. And if it is closer to 0, that means code quality is not good. That means it is low. And here, the system takes it step further by using machine learning models. So here we incorporate different machine learning models that are linear regression, random forest, XGBoost on the data it has gathered from these top performers. These models then predict the quality index for new code submissions. So instead of relying on manual evaluations, the system can automatically predict how good the code is based on the developer's past performance. The main advantage here is that it gives projects managers a more objective and a precise way to assess the code quality. They can use it to identify areas where improvements are needed, make better decisions about who to work with, and ultimately speed up the whole development process. It is more data driven and reliable approach to measuring code quality than just going off experience or gut feeling. To further improve the performance in this project, we are incorporating ensemble bagging regression model, that is the extension. As the extension, we are incorporating this model. And this model combines multiple regression models to improve prediction accuracy. By optimizing the algorithm's parameters, it can better process the training data. This results in a more robust and precise final model. And this ensemble approach ensures that predictions are more reliable by leveraging the strengths of multiple models working together. And here, frontend has been developed using Flask framework. This also includes user authentication for users. This interface allows for interactive evaluation, enabling users to test the system performance, which enhances the overall functionality and the user experience. Moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So let us understand what are the steps has been followed. First, we import essential libraries and packages that are required for data manipulation, visualization, machine learning, and web development. For data manipulation, we have imported pandas and numpy. Coming to visualization, we have imported matplotlib and seaborn. And coming to machine learning, we have used scikit-learn. And for web development, we have imported Flask. And then comes the exploring the data. Here we analyze the data to understand its structures, type of variables, and initial insights. This includes inspecting the few rows, identifying data types, and checking for any obvious issues. Then comes data visualization. Here we have explored the data. I mean, here we visualize the data using charts, graphs, and etc. to understand the trends and patterns. Then comes the data pre-processing. Here we do label encoding. So first we do label encoding where we convert all the categorical variables into numerical variables, and then we handle missing values. We we drop any missing values that data points to ensure the completeness. And then we normalize the data. We scale numerical features to ensure they are on the same scale, which helps to improve the model performance. Then comes feature engineering. Here we create new features and modify existing ones to better represent the data for model training. Here we calculate the quality index, that is the performance metrics for each user based on contest scores. And here we split the data into train and test. So here we split the data into train and test. Training set is used to train the model and testing set is used to evaluate the model. Then comes the model building part. So here we initialize the models, which are machine learning models that are random forest, XGBoost, etc. And we evaluate them using R square. And we compare them through the graphs. Coming to the front end, we have developed front end using Flask framework, which allows users to interact with the model through a user-friendly interface. This includes user registration, login, and data submission functionalities. And then comes the next part, that is user gives input. So in the front end, users are allowed to input feature values related to their code, such as contest performance metrics, which will be used to make the predictions. And then that input is pre-processed at the backend to ensure with the train model, which could be compatible with the train model. And that input is fed to the train model, and train model will be giving the prediction. That means it will be predicting the quality index of that particular code. So this is how we have implemented the project. Moving on to the algorithms used. These are the algorithms which are used in this project. So we have used linear regression, random forest, XGBoost, lasso regression, ridge regression, gradient boosting, elastic net, and the extension model tuned bagging regressor. To implement this project, we need basic requirements which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we need to open the code folder which contains source code files. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So first, let us open the dataset folder. So this is the dataset that we have used in this project. So these are the different parameters. Based on that, we will be predicting the quality index. So this is the index number, username, rank type, max reading, and these are the different contests. So this is the dataset that is used to train the machine learning models for predicting the quality index of a code. Let's close this. And here we have the test data. So in this file, we have the test cases that we will be using in the front end to predict the quality index. Let's get back. And here in this model folder, we have algorithm information that will be stored in the .h5 files, numpy files, pickle files, and that files will be loaded into the project code during runtime of the application. And here in the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. Coming to templates folder. This folder contains all HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook.ipynb file. This is the Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the command prompt. It has been opened. Now give the command cd, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folders path. Now we are supposed to compile app.py file. So give the command python space app.py and now click on enter. This command, it will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. So this is the local host and this is the port, unless configured differently. So copy this local link provided by the Flask framework and paste it in any web browser. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in. And here we are supposed to provide username and the password. So I'm giving my credentials. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see a choose file button, right? We need to click on that for uploading the test case file. So click on that. So this is the test data that we are uploading. Click on that and click on open. So before uploading this data file, that is test data file, let's see what do we have in that file. Get back to the application, sorry, code folder, open the data set. Let's open this test data. So these are different test cases that we will be uploading now for predicting the quality index of the code. And here these are the different parameters. Let's understand them. So the first one we have is the rank type. It refers to the type of ranking or performance metrics used to evaluate developers in a contest. And here we have max rating. This is the highest rating a developer has achieved in any contest. It represents the peak of their performance in repetitive coding, showing the level at which they have excelled. And here these are different contests we have from 1 to 10. These represents the individual contest scores or performance data from 10 separate coding contests. So each contest indicates how well the developer performed in that particular competition. These codes are numerical scores and the rankings depending on the system used in this contest. Now let's upload this file, get back to the application, click on upload. So here we have given the test cases that has been pre-processed at the backend, and then train model has given the prediction. So these are the different test cases that we have given. So for the developer who has these codes and the rank of master, his quality index is predicted as 0.9781. So his quality of code is 97%. Similarly, for the second case, for the second test case where the developer has been ranked as legendary grandmaster and with the contest score of these scores, it has been predicted as 0.9677 of quality index of their code. Similarly, for all the other test cases that we have uploaded, so here individual test case represents the score of individual code developers. So these are different test cases that we have given. For each test case, we got the prediction of the quality index of that particular code. So for the first case, we got 97. For the second case, we got 96. And for the next cases, we got 97. So it's like that. Now let's check with the graphs. Click on graph. Here, the first graph which we have is the correlation matrix graph. Here, this shows the correlation between individual variables. And here we have R2 score comparison graph. Here on x-axis, we have R2 score, and on y-axis, we have the algorithm names. These are the algorithms used to train the model for predicting the quality index of the code. So here we have evaluated the models using R2 score. Now click on sign out. This is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.